Okay, I'm sorry. There was some issue with my pencil. Now it is getting connected. So is my screen visible now?
Yes, sir.
Okay. So see, in Lk of x, if you see, it is product running from 0 to n, j is not equal to k. J is not equal to k, x minus xj, or x. What is happening? Yeah. So there is some issue with the pencil today. I'm not getting what is the issue. Xk minus xj. Right? So Lkx Yeah, I think that it is working now. Let me check. Okay, so Lk of x is a polynomial of degree n in x, right? For all 0 less than equal to k less than equal to n, right? Am I audible?
Yes, sir.
Okay, so Lkx belongs to P and x, right? For all n, for all k. So this implies sigma Lk, k is running from 0 to n, will also belongs to polynomial of degree n, right?
Yes, sir.
So this implies summation k0 0 to n Lkx minus 1 is okay. Is a polynomial of degree n, right? So note that Lk of xj is equal to delta ij. Delta kj 0 is less than equal to k comma j less than equal to n. Do we know this?
Yes, sir.
So basically summation k is running from 0 to n Lk of xj is equal to 1 for all j between 0 to n, right?
Yes.
So this implies, so for the time being, if I write it as f of x, instead of f of x, let me write p of x. So this implies p of xj is 0 for all j between 0 to n, right?
Yes, sir.
So basically p is a polynomial of degree n having n plus 1 zeros. What does this mean?
Zero polynomial.
P is equal to 0, or we can say summation Lk of x is equal to 1. Are we good?
So second line summation k equals to 0 to 1 L k x j equals to 1 for all.
Yes.
So if k is not equals to j, then
That's
it's
why we are using summation now.
oh, okay, sir. Okay.
Fine.
Yes, sir.
Okay. So are we good with question number 1? Are we good with question number 1?
Yes, sir.
Okay.
Yes, sir.
So have you read question number 2? It is just another representation of the Lagrange's interpolation only. If you will solve this, then it is just another representation of Lagrange's interpolation of n plus 1 points. Are you guys even reading the assignments before coming to the tutorial class, by the way?
Yes, sir.
So at least you guys must be having some reading of the questions, some idea of the question, like what is happening in the question. If you will start reading questions in the tutorial session, then 1 hour will not be enough. So in question number 2, the polynomial which is said to be barycentric representation of P of x, it is nothing but another representation of the Lagrange's interpolation only. If you will solve it.
Yes, sir.
Okay. But the thing is, if you see the second question, it is asking why barycentric representation of P of x is better than the representation which we having in the Lagrange's interpolation. So they are saying that this representation is somehow better than we are using the natural one, the above one. So why is it so? Have you thought about it?
Easy computation.
Yes, easily computationable. If I increase my number of points even, then my computations will not get affected much. See, when we are using the natural Lagrange's interpolation, the moment you have put one more node in the approximation, then you have to do all of the calculations again, right?
Yes, sir.
So
Yes,
that
sir.
is why that is computationally expensive. But when you will proceed with this barycentric representation, then it is computationally less expensive. For example, the Newton's forward difference also. It is also computationally less expensive. Although all of them will give the same polynomial, but the thing is, which is computationally less expensive? From expensive, I mean, which will take lesser time, which will take lesser number of mathematical operations. Okay. Are we good with question number 2?
Yes, sir.
Okay.
Yes,
Question
sir.
number 3 is nothing but you are given some point, you have given some function, you just need to find the approximate polynomial, and then you have to approximate the polynomial at certain point, which is 0.45. So can you guys do question number 3 on yourself? It is just mere computational work.
Yes, sir.
Yes, sir.
find f of 0.45 and the exact value, for example, f at 0.45 and cos at 0.45. You need to find the error. So this is one of the most simplest question I suppose. Okay, let's go on. So two of you have you tried question number 4? Is there any doubt in question number 4? Please speak up.
No doubt.
No
No
doubt.
doubt, sir.
Sure. So can anyone tell me what should be the procedure? How will we approach this question?
सर एक्स नॉट x1 एंड x2 गिवन है सर। x1 पे मतलब हमें लार्जेस्ट वैल्यू फाइंड करनी है, तो सर x1 को सपोज x मान लेंगे तो हमें एक पॉलिनोमियल x पे मिल जाएगी। तो ये गिवन है कि f 0.5 माइनस p2 0.5 इक्वल टू माइनस 0.25, यहाँ से एक मुझे फंक्शन मिल जाएगा। फिर मुझे यहाँ से हम इसकी मैक्स वैल्यू निकाल सकते हैं इन वन वेरिएबल।
Okay. So have anyone solved it and find the answer?
Yes, sir.
What is the
0.8726.
answer?
0.8726.
Okay, so I haven't calculated it is, but I have calculated was 3 plus root 5 by 6.
Yes, sir. Yes, sir. 3 plus root 5
I
upon
think
6.
both are the same thing.
Yes, sir. Both are same.
Fine. Is question number clear? Is question number 4 clear to everyone? If anyone have any doubt, please ask me now. Okay. Proceed to question number 5. So what do we need? What do we need to do in question number 5 now?
We have to find interpolating polynomial, then find remainder.
So a polynomial which you can easily find by f1, f2, and f3. The most trivial one, the Lagrange's interpolation you can do here, and then you have to divide that polynomial by x minus 4, right?
Yes, sir.
Yes, sir.
So question number 5 can be done.
Yes, sir.
Yes.
Okay, what about question number 6? Has it been discussed in class?
Yes, sir.
Question number 6. Okay. So he asked me to show you the figure for question number 6. So let me do that. 1 plus 25x square. Then across the edges you can see. across the edges, you are having very high fluctuations. So that's why when you increase number of degrees of freedom, or if you increase number of nodes, equally spaced nodes, then this will be the trouble. So your error will keep on increasing. You- And the blue one is the approximate solution, and the second figure depicts the error. Okay.
Sir, but how to show mathematically?
I think it has been discussed in the class.
I don't remember. Ma'am just said theoretically that it will happen.
Okay, and when I asked her, she said that you just need to show the graph of it, and else has been discussed in the class.
Okay, sir, I'll check lecture.
Okay, if I give you, okay, so let me give you a brief idea about it. So what do you, so you have f of x, right? 1 upon 1 plus 25x squared. Do one thing, find f prime x, double prime x, and find some 2 or 3 iterations, because you know that the error is somehow dependent upon fn plus 1 xi, right? Into those x minus x naught, x minus x1, and so on x minus xn, right? 9 plus 1 factorial. Something of this sort. You know this thing, right? For the Lagrangian interpolation, this is the error.
Yes, sir.
So when you do the derivatives, you will see that the value of f prime f double prime, the
Sir,
maximum value of these
you're audible.
You are not audible properly.
Yes, sir, your voice is breaking.
keeps on increasing. So if I tell you, so f of x is hello.
Sir, you were not audible.
Yes, sir, you're not audible.
Okay, if changed to internet connection, then hello.
Yes, sir. Now audible.
Okay, thank you. So what I was saying is, so fx is 1 upon 1 plus 25x square, right? So if you go to the maximum value of fx, it is going to be 1 at x is equal to 0. I am just giving you the idea, I'm not saying it is the exact true. If you go to f prime x, then it will be around minus 50x on 1 plus 25x, right? and maximum value of f prime x will be 15 square root 3 upon 8. At x is equal to 1 upon 5 root 3. I'm sorry, my internet connection is getting very unstable today. Am I audible at present?
Yes,
Yes,
sir.
sir.
Yes, sir.
So when you go to the higher derivative, say f n plus 1 xi, so it will be somehow dependent upon n plus, I think, 2 factor or something. Okay, you can find it on Google also, or you can do it on your own. So when we will do fn plus 1 xi upon n plus 1 factorial, it will be somehow n plus 2, which will go to infinity, and then goes to infinity. So this is some vague idea for question number 6. Like, as when we increase the number of nodes, when we are increasing the degree of the polynomial, our f prime is getting increased very rapidly. Or, and for more explanation, you can refer to your notes. Are we good with question number 6? Okay, let us proceed to question number 7. Have anyone tried question number 7?
Yes, sir.
Yes, sir.
So, are you guys able to do it?
Yes, sir.
Okay. So, what is the idea you guys have done there? So, what is the idea we have tried for question number 7? Have you guys solved the whole determinant there? Hello? Have you guys solved the complete determinant, or you guys have used some kind of trick here?
Yes, sir.
I didn't get you.
Induction.
Induction can one of the way. Apart from induction, from the theory which we are reading here, some Lagrange's interpolation kind of thing, some interpolation kind of stuff. Okay, let me give you an idea here. So let us do for n is equal to 3, okay? So for n is equal to 3, we will having 4 cross 4 matrix, right? So it will be 1 x naught square, x naught cube, 1 x1 square, x1 cube, 1 x2 square, x2 cube, 1 x3 square, x3 cube, right? So determinant of x will be this, right?
Yes, sir.
Okay. So if you see, so it will be a polynomial, fine.
Yes, sir.
So something say x1, x2 square, x3 cube, and something, right? Something of this sort it will come. So this will be one of the term, and then there will be many more terms.
Yes, sir.
Okay. So what we can see is the highest degree of this polynomial can be what? 3 plus 2 plus 1, right? 6. It cannot cross 6. Anyhow, it cannot cross 6, right?
Yes, sir.
Because what you can do, you can just solve the determinant across column 1, right? So determinant of x is some sort of polynomial of degree 6, or you can say yeah, 6. Yeah, fine. Till here, is it fine?
Yes,
Yes,
sir.
sir.
Okay. So try to substitute x naught is equal to x1 in here in star. If I put x naught is equal to x1 here, then what it will be? 1 x1 x1 square x1 cube 1 x1 x1 square x1 cube x2 x2 square x3 square x2 cube x3 cube, right? Which is 0 because two rows are identical. Are you getting this? I am not doing anything. I am just substituting x naught is equal to x1 for the time being. Hello.
Yes,
Yes,
sir.
sir. Yeah.
So what does it mean? X naught minus x1 divides determinant of x.
Yes, sir.
Are you getting this point?
Yes, sir.
So in similar fashion, x naught minus x2 will divide determinant of x. X naught minus x3 will also divide determinant of x. X1 minus x2, x1 minus x3, and x2 minus x3 divides determinant of x, right?
Yes, sir.
So are you guys now getting some idea why determinant of x will be this only? You just need to do the product of everyone.
Yes, sir. Degrees at most 6.
Both are a polynomial of degree at most 6. Is question number 7 clear?
Yes, sir.
Okay. So can I assume that we are done with
Sir,
assignment
what about
3?
sign?
What?
What about sign? So here we can also take x1 minus x naught. So
Yes,
how?
that you can take. What we are saying is two polynomials of same degree are equal. See, instead of this x0, x1, x2, x3, if I, for the time being, say, I give you x1 is equal to, say, 1, x2 is equal to 2, x3 is equal to 3, and x0 is equal to x. Probably that can help you out. So then it will be 1x, x square, x cube, 1, 2, 4, 8, 1, 3, 9, 27, and 1, 4, 16, 64, right? So now if I say it is a polynomial of degree at most what?
3.
Will it be degree of at most 3? Okay, yeah. For the timing we are doing like this. Okay, so p of x will be something, I don't care, but it is a polynomial of degree 3, at most 3, right? Then you can see that p of 2 is 0, p of 3 is 0, p of 4 is 0. So basically when I say p of 2 is 0, this implies x minus 2 will be a factor, x minus 3 will be a factor, and x minus 4 will be a factor. And you can definitely put some a here, some constant a, 1, 2, 3, minus 1, minus 2, some sign here, right? If I say fs is some polynomial and I do not specify the degree, but I say is f of 2 is 0, f of 3 is 0, f of 4 is 0, right? So what do we write? fx is equal to x minus 2, x minus 3, x minus 4 into some g of x, right?
Yes, sir.
So now I am claiming that fx is a polynomial of degree 3. So it has to be a polynomial of degree 1. So some constant a, right? So some constant multiple, right?
Yes, sir.
Okay. So when we are doing it here, then fx. So if you put x is equal to something else, see, I have put an x is equal to x. So let me make it clear. We know that p of 2 is 0, p of 3 is 0, p of 4 is 0, but p of x is also 0, na? When I am solving the determinant. See, when we are doing it here, we are having a polynomial of degree at most 6. And we are having x0, x1, x0, x2, x0, x3, x1, x3, x2, x3, and x0, x6. So both are polynomial of degree 6, and both are getting equal at 6 points. Okay, probably I'm doing some mistake here. We need a polynomial of degree 5 then, right? Just give me some time, I will get back to you. Probably I'm confusing yourself, you all. Just a second. Okay, let me explain it again. Yeah. So what we are doing, 1 x naught square, x naught cube, 1 x1 square, x1 cube, and x2 square, x2 cube, x3 square, x3 cube, right? So it is my determinant of x. So if I solve this, then what I know is x1 x2 square into x3 cube has coefficient 1, right? That is true, right? I am just solving it along first column first, then determinant of this, then x1 will be out, then x2 square and x3 cube. So the coefficient of this term in determinant of x will be 1, right? Is it making sense? Is it making sense that coefficient of x1 x2 square x3 cube is equal to 1? Say yes or no at least. Hello.
Yes, sir.
So the coefficient of x1 x2 square x3 cube is 1. That is fine, right? And now do this, x1 minus x naught, x2 minus x naught, x3 minus x naught, then x2 minus x1, x3 minus x1, and x3 minus x2. Because we know that all of these are the roots of the polynomial determinant of x. So determinant of x will be this times some polynomial q of x, right? That's what we have understood till now.
Yes, sir.
So see, determinant of x is a polynomial of degree 6 and this is a polynomial of degree 6 plus degree of q of x, right? So q of x is a constant, first of all.
Yes, sir.
So now q of x is equal to some constant a. Then if I solve this one, so what I will get as the coefficient of x1, x2 square. Okay, so I can write this thing as x1 minus x naught, x2 minus x naught, x2 minus x1, x3 minus x naught, x3 minus x1, and x3 minus x2, right? Into some a. Then coefficient of x1, x2 square into x3 cube will be what? A.
Yes, sir.
Two polynomials are equal, so the coefficient has to be equal,
Yes, sir.
and coefficient of x1, x2 square, x3 cube was 1.
1.
So this implies a is equal to 1.
So can you please explain how the coefficient is 1?
Of
x1, x1,
here,
x2 square, x cube, cube.
here.
Yes, sir.
So see, when I solve using first row and first column, so I will get 1. So this and this will get cancelled, and determinant of this x1, x1 square, x1 cube, x2, x2 square, x2 cube, x3, x3 square, x3 cube, right?
Yes, sir.
Plus something will be there. We are not very bothered because whenever you will do any other row or column, then these entries will not be repeated. Either x1 will not be there, or x2 will not be there, or x3 will not be there.
Okay, sir.
If
Got
I'm
it.
doing it along columns, sorry, rows, right? If I'm expanding it around column 1, so then whenever I will take second row first column, or third row first column, then at least x1 row will not be there, or x2 row will not be there, or x3 row will not be there. Fine.
Yes, sir. Now I got it.
See, okay, so if I do it then minus 1, then